So welcome to you all, Module 3 Class 3. So in the previous class we have already seen the concept of one-dimensional array. Some of the example programs also we have seen. In today's class we will discuss the concept of sorting. So sorting is the concept wherein we sort the elements of the array either in ascending order or in descending order. That is either in increasing order or decreasing order. We'll learn the two algorithms. One is the bubble sort algorithm, another is the selection sort algorithm. Now we'll see the bubble sort algorithm. So the bubble sort algorithm sorts the elements of the array in ascending order. Now we scan the array element from left to right, and if the elements are not in ascending order, then we swap them to sort them in ascending order. So every time we scan the array from left to right, we end up sorting the one element in ascending order. Now example we have taken here, 4, 3, 1 and 2 are the array elements. Now first I'll start scanning the array element from left to right. So first element is 4. Now 4, I'll compare it with the adjacent element, that is 3. Since 4 is greater than 3, that means 4 and 3 are not in ascending order, so I swap 4 and 3. Now I compare 4 with the next adjacent element, that is 1. Now since 4 is greater than 1, so they are not in ascending order, so I swap 4 and 1. Now again I will compare 4 with the next adjacent element, that is 2. Since 4 is greater than 2, they are not in order, so I swap 4 and 2. Now I have reached the end of the array. Now if you see, the largest element, that is 4, is placed in the appropriate position, that is the last position in the sorted array. So since at each scan we end up sorting the highest element or the highest element bubbles out to the sorted position in the array, so that's why it is called as bubble sort. Now once I have scanned and one element, that is 4, I have sorted and placed it in the last position of the array. So now I'll start the comparison or start the scanning from the left side of the array. So now the first element is now 3. So 3 and 1 I'll compare. Now again 3 is greater than 1, so I'll swap 1 and 3. Now I'll compare 3 with the adjacent element 2. Since 3 is greater than 2, so I'll swap 3 and 2. Now I have placed the second largest element 3 in the last but one position in the array. So now I have to compare. So now two more elements are remaining. I'll have to again scan the array to sort them in ascending order. Now 1 and 2 I will compare. Since 1 is less than 2 and they are in ascending order, so I need not swap them. Now the entire array is sorted in ascending order, 1, 2, 3, 4. So here 4 elements are there, so 3 times I will have to scan the array, and at each time I will have to compare the adjacent elements. If they are not in sorted order, then I will swap them to make them in or to bring them to sorted format. If they are in increasing order, that is in ascending order, then I need not swap them. So now we will see the program. So hash include HDIO.h, that is for standard input output library functions. Then void main marks the beginning of the main function of the program. Now I and j are the two integer variables I have declared here to access the array. A is the array I have declared here, and the size is 10. It can hold up to maximum 10 elements. I have made use of another variable temp here, temporary variable, to swap the elements. I need a temporary variable. For that purpose I am using the variable temp. Now next, enter the array limit, that is the number of elements to be inserted in the array. and that limit whatever user specifies will be stored in the variable n. Then after that enter each element of the array and store it in the array a of I. That a of I is used to access the array and store the elements in the array. For example, here I have taken n as 3, so I can run from 0, 1, 2. So the values I have given here is 4, 1 and 2. First value, that is a of 0 is 4, a of 1 the value is 1, a of 2 the value is 2. So since we will be sorting the array, that is the same array variable whatever we declared, in the same array we are going to sort it. That is why before sorting itself we will print the actual content of the array. So printf the array before sorting, again I equal to 0, I is less than n, I plus plus. So printf %t slash t. This is because I want to display the contents of the array with one tab space. So for I equal to 0, 0 is less than n is 3, so 0 is less than 3. So condition is true, so the control will come inside. Printf %t slash t. So a of 0 the value is 4, so 4 will be printed. Then again I plus plus, I will be incremented by 1, so I becomes now 1. 1 is less than 3, condition is true, so control will come inside the for loop. %d a of 1, the value is 1, I give slash t, so one tab space will be left and value 1 will be printed. Now I is 2, 2 is less than 3, condition is true, so the control will come inside the printf. Now a of I is a of 2, the value stored is 2, 2 will be printed, I will be incremented by 1, I becomes 3, so 3 is less than 3, the condition is false, so the control will come outside the for loop. Like this the contents of the array, the original contents of the array will be printed. So now we have entered the array elements and stored the array elements in array A. The elements are 4, 1 and 2. Now the sorting starts. So the outer for loop here, for I equal to 0, I is less than n, I plus plus. This is to count the number of times we are supposed to scan the array. As we have seen in the previous example, there are 4 elements I had taken. So I had to scan the array 3 times. So 1 less than the number of elements. So here that's why I have given I equal to 0, I is less than n. Since in this example number of elements are 3, so 0, 1 and 0, 1, that is 2 times I will have to scan. So I start from 0, I can go up to 0 and 1. So n is 3 over here. Then the next for loop, J for loop, is used for comparing the adjacent elements and sorting the elements of the array. That is why it goes from 0 to n minus 1 minus I. As and when the first scan is over, last one element will be sorted. So next time when I am scanning the array, so remaining elements, only remaining elements I will have to compare. That's why it runs from n minus 1 minus I. So now start the comparisons over here. First iteration, now I equal to 0, n I have taken it as 3 over here. So I can go maximum to 0, 1. So 0 is less than 3, condition is true, so the control will come inside the second for loop. Now j equal to 0, so j is less than n minus 1 minus I. So n is 3, 3 minus 1, that is 2, 2 minus the 0, so that is 2. So 0 is less than 2, so the condition is true, so control will come inside the for loop. Now I am checking if a of j is greater than a of j plus 1. I am comparing the adjacent elements. A of j is a of 0, a of j plus 1, that will be 0 plus 1, that is a of 1. So I am comparing a of 0, the element is 4, and a of 1, the element is 1. A of j, that is 4, is greater than 1. So the 4 is greater than 1, the condition is true. Since 4 is greater than 1, now I have to swap them. So temp equal to a of j. So a of j, the value is 4. 4 will be moved to temp. Now a of j is equal to a of j plus 1, that is a of 1. A of 1, the value stored is 1. So 1 will be moved to a of j. 1 will be moved to a of j. Then temp, a of j plus 1 equal to temp. So 4 will be moved here. So 1 and 4 are sorted. Now the control will come back to the for loop. J for loop. J is incremented by 1. J was 0. J is incremented by 1. J becomes 1 now. So the condition is checked here again. 1 is less than 2. So the condition is true. So the control will come inside. Now a of j is greater than a of j plus 1. A of j is a of 1 is greater than a of j plus 1. 1 plus 1, 2. A of 2. So a of 1, the second iteration you can see here. A of 1, the value is 4. A of j plus 1, that is a of 2, the value stored is 2. 4 and 2 are compared. 4 is greater than 2. The condition is true. So again we are swapping here. So 4 is put into temp. Then whatever was there in j plus 1 will be moved to a of j position. So 2 comes here. Then from temp, whatever value is stored, that is 4, is moved to j plus 1 position. So now 2 and 4 are swapped. So now the control again goes back here. J is incremented by 1. J becomes 2 now. So 2 is less than 2. The condition becomes false. So that is now 1, 2 and 4. So now the largest element 4 is placed in the last position of the array. So this condition becomes false. So control will directly come out and go to the outer for loop. Now I will be incremented by 1. I was 0. I becomes 1 now. So 1 is less than 3. Condition is true. So control will come back inside now. For j equal to 0, j is instead 0 now. 0 is less than n minus 1 minus I. N is 3. 3 minus 1 is 2. 2 minus I value is 1 now. 2 minus 1 is 1. So 0 is less than 1. Condition is true. So control will come inside here. Now if a of j is greater than a of j plus 1. A of j is a of 0 greater than a of j plus 1 is 1. So a of 0, now the value what we have at a of 0 is 1 and a of j plus 1 is 1. So a of 1, the value is 2. 1 and 2 are compared. So 1 is greater than 2. The condition is checked here. 1 is greater than 2. Since the condition becomes false, since 1 is not greater than 2, so control will directly come here. J is incremented by 1. J was 0. J is incremented by 1. So 1 is less than 1. The condition becomes false. So it will come outside and it will go to the outer for loop. Now I is incremented by 1. I was 1. I becomes 2 now. So 2 is less than 3. So again condition is true. So control will come back inside here. Now j equal to 0 and n minus 1 minus I. N is 3. 3 minus 1 is 2. Minus I is 2 now. 2 minus 2 is 0. So 0 is less than 0. Condition is false. So control will directly come outside here. I is incremented by 1. I was 2. I is incremented to be 3 now. So 3 is less than n. N is 3. So 3 is less than 3. Condition is false. So directly control will come outside the for loop and it will execute whatever instruction given next to this curly braces. This indicates the end of the outer for loop. Since all the elements of the array are sorted now we have to display the contents of the array. So now we have sorted the array. Now we have to display the sorted array. So printf, we enter the printf the array elements after sorting at your /n so that the cursor will go to the next line. Now for I equal to 0, I is less than n, I plus plus. So I can run from 0, 1, 2. So printf %d /t I have given. So a of 0, a of 1, a of 2. The contents are 1, 4 and 2 will be displayed. And this is the closing of the main function. You can check the output over here. Execute the program and then check the output.